So now we have team CDAC-SVNIT. Let's know about their idea and overview of the project. So,
Yeah. Hi, we are Team CDAC-SVNIT. As the name suggests, we are two institutes, Center for Development of Advanced Computing and Sardar Vallabhbhai Patel, National Institute of Technology, Surat. We collaborated for this very project. It was a very interesting challenge, and we built a multilingual, multi-speaker unified TTS framework with speaker style transfer. So for that, we used a WITS model, and our innovation in that was we didn't use the grapheme to phoneme conversion that is usually followed in a text-to-speech system, converting to phones. So we used the grapheme and we unified the vocabulary for the 11 languages that we have been given. So it was a inventory of 500 characters, which included Devanagari characters, Tamil, Telugu, Kannada, and Bengali, of course, and Magahi, Maithili, Chhattisgarhi. They shared a common inventory of characters, that is Devanagari. And for the sake of this challenge round, that was voice cloning was there. So we did it in the second stage. In the first stage, we generated the synthesized voice, and in the second stage, we applied Hubert model to and extracted the reference clips, speakers embedding, and injected in the synthesized audio. So in this way, combining stage 1 and stage 2, we generated the cloned voice. Yeah. And Apollo?
Yeah. So normally most of the TTS models are fine-tuned models. Instead of relying on a single fine-tuning model, we created two-staged models. One is for creating neutral speech synthesis, and another one is for voice conversion or for voice cloning. So that where we can include the speech and the neutral speech encodings as well as the speaker encodings to finally generate a cloned output. Okay, so the major takeaway from this challenge or from our model is to create a smaller model which is able to do multilingual and multi-speaker TTS outputs. So you can see that for inferencing, even though we used a A100 GPU for training the WITS model, for inferencing we used a very small compute model which is RTX 6000, which has only 16 GB VRAM. So the requirement for the model is not that much. So normally if you are going for a fine-tuned TTS model which requires more compute, you may require a A100 for inferencing as well. So this will be useful for taking this model into edge devices, and we can create mobile application. And currently we have reduced the model size to 70 MB for one language. Okay, so if we are considering all languages, we can reduce it to inside 200 MB. So this was thing, and we also tested our outputs, and the accuracy, the MCD, like the acoustic fidelity, was in the range of 4 to 9, which is considered to be a very good TTS output score. So, and as well as like we used word error rate to find out like whether whatever the TTS is generating is actually identified by the ASR systems or not. So there also we got good results. Some results are slightly higher side because it depends on the model, ASR model which we are using. We are using Whisper ASR, which is which doesn't provide good ASR system for all Indian languages. It is good for Hindi and some other languages. and this is it. And like we can now currently handle 6 requests per second, and we can also make it faster as well. And if anybody has any questions, we can ask. Yeah.
So it was great knowing about your team. So what was the most challenging thing you faced, sir, while while like creating the models?
Yeah, the most challenging was again this compute infrastructure. Even though we are in CDAC and we have Param Siddhi, but getting that resource is very difficult. We had to wait for the queue, and the queue was around 3 to 4 days of time. So we had to submit the job, and so this is again very good thing about our model is that it is lightweight, and it has significantly lower parameters. So it takes around only 1.5 day to reach to this stage. 1.5 day is enough for building training out this model. And second was again related to infrastructure only. The amount of data that we had given, it was.
That's why we could only train our model, or we could not train our model on all the data. We could only train on a sample of data because of the limitation of compute resources.
Only the female voice is being trained here.
Yeah.
Though the Spire and CESPIN has provided male and female voice that we could have used, but due to storage and compute infrastructure problem, we used only the female voice. So half of the data is from CESPIN only, and no other data set. So that was all. Thank you.
Yeah, it was nice knowing about the team. Any questions from the audience? Please.
Can you give more details on how you cloned the voice of an arbitrary unseen speaker using only 1.5 second reference clip?
For that we leverage the Hubert model. It basically extracts the speaker embedding from the reference clip itself, and it injects it into the synthesized voice generated in the stage 1. Though this stage 2 was not required for this TTS, but for the challenge sake we had to introduce free VC here. Otherwise this model is sufficient. One speaker can speak any of the language.
Yeah.
A Bhojpuri speaker can speak English as well as Bengali, code mixed text and everything.
What was the WER for South Indian languages? I see some North Indian languages and English.
I think Whisper AS
No, we did not. Due to lack of space, we did not put it. So it is also in the range of so maximum 8 and minimum 8 and maximum 22. So it lies in that range only. In that range.
Okay, sir. Thank you so much. It was great to know about your team. Let's meet new team.